Right, so now we've talked about how we can find a regression line equation. One thing that we've been seeing happen in a lot of these previous sections is that we're asked to interpret or put this in context. So that's what we're going to focus on in these next few examples. Again, I went ahead and kind of cheated. I wrote out all of these different things just that way you don't see my hand on the page, and I can kind of more discuss and talk about why we have the answers that we do instead of having you just sit there and watch a video while I write out the answers. So when we're interpreting the regression line, we're going to have two separate interpretations. We're going to have an interpretation of our slope and one of the y-intercept. All right, so our slope is going to be written as a decimal. So what that means is if we think about our slope is rise over run. If we write our slope as a decimal, that means that our denominator is equal to 1. So our slope tells us how much the y variable changes when the x value increases by 1 unit. Right? So our x value is moving to the right by 1 unit, so how much is the y variable changing? Right? So it increases if it's positive, or if we happen to have a negative slope, then it is decreasing. Right? A slope close to 0 means there is no linear relationship between x and y. So that is kind of one other thing to mention. When we're interpreting our y-intercept, the y-intercept is the predicted value when x equals 0. Right? So we're always going to think about our y-intercept, or we do usually think about our y-intercept as an ordered pair, right? Where our y-intercept is 0 for x, comma, some number for y. The y-intercept is meaningful only if it makes sense for x to equal 0. And we'll kind of see what we mean as we look at this first example. Sometimes our y-intercept is useful information. Sometimes it's not something that's going to be useful for us. Right. So we're going to go back to our height and weight example that we've been looking at in the last couple of sections. And we're going to talk a little bit about this equation. So the regression line equation that we get, weight equals negative 442.882 plus 9.029 times height. What does the regression line equation tell us? Interpret the slope and the y-intercept. So we'll start with the slope. The slope tells us that the weight, which is y, tends to increase because the slope is positive, 9.029 pounds, because that's actually the amount of the slope, for every 1 inch in height. Right? So height is our x value. So as our x value increases by 1, right, the slope tells us that our y value, our weight, increases by 9.029 pounds. And there's a bunch of different ways that you can kind of phrase this, but those are the key things that you're looking for. Right? Your y variable, what is it? What is it doing? Increasing or decreasing? Right? And it's doing that for every time the x variable increases by 1. So that's what our slope is telling us. Slope is sometimes referred to as a rate of change. Right? So for each additional inch in height, right, the rate of change, the weight is changing by 9.029 pounds. Right? Then we talk about our y-intercept. Our y-intercept tells us that a woman that is 0 inches tall tends to weigh negative 442.882 pounds, because our y-intercept is negative 442.882 pounds. Right? This is a case where it doesn't make sense. This is not useful information. Right? This is not useful information because it's impossible for a woman to be 0 inches tall, number one, and it's also impossible for a person to weigh negative 442.882 pounds. So the slope we can always talk about. The y-intercept, depending on the problem that we're looking at, it may or may not be useful information. It may or may not make sense in the example that we are looking at. Right? So again, at this point we've kind of concluded and looked at everything, all of the different pieces for chapter 4 that we can look at for this example. We created a scatter plot for this example. We talked about our correlation coefficient, that we had a relatively strong positive linear trend. We created our regression line for this equation, and not only did we create our regression line, we also did some interpretations. Right? The only thing we kind of left out was making a prediction. But if we wanted to make a prediction, we could take this regression line and also use that to make predictions as well.